Oh, you're not doing Tony. Daddy saved you.
Yo, what's up, everybody? I'm back for video number two. Video number two is dealing with chapter two, which is all about chemistry. So if you haven't watched chapter one, you need to go back and check out chapter one, video number one. This one is just dealing with chapter two, and I'm just doing just a basic run through on some key things for chapter two. Now, I will say this: if you have gone through chapter two and you hated it, good. Because chapter two is chemistry, and not too many people like chemistry. I can't claim to love chemistry, but I like applying chemistry. There's a difference. Liking chemistry, I don't know about that. Applying chemistry, oh yeah, all day. Because once you start understanding chemistry, you will actually become a better cook. Believe you me, I took a chemistry and biochemistry class. Like I told some of you, I'm back in school myself. And last year I was taking a chemistry and biochemistry class. And what was crazy was we were talking about this thing called Maillard's reaction. Maillard's reaction sounds like a really corny reaction, sounds like something extremely difficult to learn because it's talking about organic nutrients like proteins. And then you find out that Maillard's reaction helps you understand how to cook a steak. So now, hey, I will put my steak cooking skills up to some experts because I understand Maillard's reaction. I understand what heat does to a steak, and I understand how caramelization works and everything. And that comes from chemistry. That comes from chemistry and biochemistry. So understanding chemistry and biochemistry will help in ways that you never imagined. So let's jump into chapter two real quick. There's a lot of stuff going on in chapter two because it's really trying to get you through a wide range of chemical, a wide range of chemical concepts. If you've had chemistry in the past, and I know some of you have talked about the fact that you've had chemistry already, then this chapter is really good for review. If you've not had chemistry before, hold your breath, let it go, take a deep breath. It's all good. There's not a lot in this chapter. It's not as much as you think. First, it starts off telling you the basics like matter. Why does matter matter? Because matter is anything that takes up space and has mass. In other words, anything that takes up space and has weight. So this laptop that I'm talking to right now, it's taking up space and it weighs something. The water in my water bottle beside me, it is taking up space and it weighs something. That's why it's called matter. So we are surrounded by matter and we are made out of matter. The thing about it is that when you break matter down to its basic pieces, it's made up of stuff that is rather common and that they have in common. So you will find that even though you and your pet dog don't seem to have a lot in common, when you break yourself down to the basic compounds, you'll find that you guys are made out of the same stuff. And that's crazy. So you'll also learn that in order to make some things in the body, you just have to have the right building blocks. And if you understand the chemistry chapter, then when we utilize those building blocks to build something, it won't be as confusing. So you have to understand that an atom is smaller than a molecule. You have to understand that an atom is made up of subatomic particles, subatomic particles, like a neutron, proton, and an electron. You come to find out that they have different charges on them. An electron has a negative charge, a proton has a positive charge, and a neutron has a neutral charge, which is great because most of their charges are dependent upon something that sounds relatively close to their name. Positive proton, neutral neutron. All right. Now, when you start changing the number of subatomic particles in an atom, you start playing with that dude and his attributes begin to change. That's how you make isotopes. That's how you create ions, because with an ion, you have an uneven number of protons or electrons, which produces a charge. And once you produce a charge, that's very important because once you produce a charge, you can actually stick certain ions together. They'll be attracted to one another because opposites attract. And in this case, some ions do that as well, like sodium and chloride. Sodium ions are positive, chloride ions are negative. Sodium ions are positive because they got more protons and electrons, and chloride ions are negative because they got more electrons than they have protons. And so those positive and negatives attract, and it sticks sodium and chloride together to make table salt. So the elemental chart, when you look at the element table, you'll see all these different elements. All these different elements exist somewhere in this universe, and some of them interact with one another very good. They get along with one another very good, and others don't get along with one another at all. We, for anatomy and physiology, are going to stick to some rather basic elements. We're not going to traverse across that table a lot. We're going to stick to a lot of basic things like sodium, nitrogen, oxygen, carbon, chloride, magnesium, manganese. I think I said carbon already. So nitrogen, we're going to stick to some very, very basic elements near the top of the table to really discuss the makeup of the body. Now, another thing that chapter 2 talks about that you really need to remember are the difference between acids and bases. Acids and bases get a bad rap because oftentimes people think that acids are just bad things, bases are good things, la la la, and they go on about their business. But what they don't realize is that's not true. An acid is nothing more than something that contains a lot of hydrogen ions in it. Something that is basic is something that has a lot of hydroxide ions in it. So you have less hydrogen ions in a base, and you have more hydrogen ions in an acid. This will directly affect how that substance functions, as well as substances around it. So you can't say that one is bad and one is good, because if you said, oh, acidic is all bad stuff, well, that's not true, because if you drink wine, then that makes, wine is acidic. So that would mean that it was bad. Beer is acidic. Ooh, I got one for you that you didn't know. Did you know that milk is acidic? Yeah, milk is acidic. Now, milk is not as acidic as tomato juice or lemon juice. But guess what? I just named 3 things that are totally edible, that's totally awesome, and they're acidic. Orange juice is acidic. So you can't say all things that are acidic are bad. You can't say that all things basic are good, because oven cleaner is very basic. You don't want to drink that. Clorox is basic. You don't want to drink that either. So there are things that are made basic and acidic for a reason, and we just have to keep that in mind. Oftentimes the body is having to neutralize one or the other. So if things in your body are too acidic, your body will try to counteract it with something that's basic. And if your body is too basic, then your body will attempt to counteract it with something that's acidic. You have to remember that they are two opposites. You definitely want to pay attention to the pH meter, where it goes from 0 to 14, and the fact that the pH of 7 is neutral. So a pH of 7 is neither acidic nor basic. That's why water is such an important thing to your body, because your water is slightly basic. If 7 is neutral, water is anywhere between 7.35 and 7.45. Water is always slightly basic, and it keeps your water is actually neutral. I should say water is more neutral than anything, but it makes your blood slightly basic. Sorry, saying that wrong. Water is neutral. Water is a pH of 7, but because your blood is made out of so much water, it actually makes your blood a pH of 7.35 to 7.45. Now, the reason why your blood is going to be slightly basic is because the waste products that your cells create are acidic, like lactic acid. So if you're making all these acids all day long, you're throwing them into the blood. The blood needs to be slightly basic to offset the acidity, because an acidic environment in your body actually shuts cells down. Tissues in your body don't like an acidic environment. Just ask a muscle that is surrounded by lactic acid. It will begin to lock up, and it'll begin to stiffen, because a muscle cell does not function very well in a very acidic environment. So I'll use my back for an example. I said in the first video, I talked about how I got a minor tear in my back. So one of the things that was causing me so much pain is that there was a slight tear in a muscle in my back. And so my other muscles around it were trying to respond to that and trying to rescue me from that pain. So my other muscles decided to contract. Well, as they were contracting, they were beginning to fatigue. And when they fatigue, they're producing lactic acid and they're running out of energy. And so the area is becoming even more acidic, which is causing my muscles to break down and become in even more pain. So they had to give me a muscle relaxer to relax those muscles so they wouldn't continue that activity and just cause me more pain and cause more damage. And that's one of the reasons why they give you muscle relaxers in a situation like that. So yeah, what you want to remember is acidic and basic. Don't learn it as bad and good, because that's going to mess you up in a class like this. That's not how things work in science. Acid is not bad. Acid is just dependent upon where we're using it, and a base is not good. It's just dependent upon where we're using it. You'll also find that when we talk about acids and bases, how things can change in an acidic environment. You can't create the enzymes necessary to digest food in your stomach without your stomach becoming an acidic environment. If you make your stomach too basic, then the enzymes who are supposed to help you digest protein won't activate. The enzymes that digest protein in your stomach have to have an acidic environment. So acidic is good in your stomach. On the flip side, if you have too much acid in your stomach, you could get acid reflux, which is why they give you an antacid. It's something that's a basic property. It has basic properties that helps to neutralize, acts as a buffer to neutralize the acid that's in your stomach. The last thing I wanted to touch on from chapter 2 is talking about the organic nutrients. Now, sometimes people skip over this. Now, I can tell you want to understand it because I'm going to have questions about it on the lecture exam. So let's just go ahead and let that cat out of the bag right now. No need to sit there and have him scratch everybody up. Let the cat out of the bag. There'll be questions on the test about organic nutrients. The thing you want to remember about organic nutrients is, number one, you want to remember that we know them commonly as very large molecules, but very rarely do we think about the fact that they're broken down into smaller molecules. I'll give you an example. Let's say that my friend Jamal hears that I want to build a wood deck on my house. So let's say I go to his house and I'm telling him that I want to build a wood deck on my house. Excuse me. This is about to get worse. Let's say that I tell him I want to build a wood deck on my house, and he thinks that that's a great thing, and my birthday is coming up, and so he stops by the house. He says, "Come outside, Julian, I want to show you something." And there in my yard, he drops off a 40-foot tall pine tree and says, "Hey, man, I heard you wanted to build a wood deck on your house. Here's a 40-foot tall pine tree. Happy birthday." So my question to you is that a bad thing or good thing? Think about it for a few seconds. Okay. So, you might say, well, Julian, that's a bad thing. He brought you a 40-foot tall pine tree. And then some of you might say, that's a good thing because you said you wanted to build a wood deck, and him bringing a 40-foot tall pine tree may work in your favor. Well, you're both right. It's good and it's bad. It's good because I asked for wood to build this wood deck. And so 40-foot tall pine tree is a good thing. The bad thing is I can't utilize it because it's still in its state as a tree. I can't manipulate the tree. I don't have the tools at my disposal to manipulate the tree, to break it down to its smaller constituents, to be able to build this back patio. However, if Jamal brought that 40-foot tall pine tree and some tools, and we took the time with a sawmill toolkit to break that tree down into 2x4s, 2x6s, and 2x8s, then I could have that porch built and I could be out there with my smoker and really having a great summer. So here's the deal. That 40-foot tall pine tree is that hamburger you had for lunch. It's that piece of fish that you had for dinner. It's those French fries you had for a snack. That's a 40-foot tall pine tree. Your digestive system has to take the time out to break that 40-foot tall pine tree into small enough pieces that the cells of your body can actually manipulate. Because if I take that French fry and I lay that French fry in front of some of your cells in your body, those cells will look at you like they're looking at that 40-foot tall pine tree. They'll shrug their shoulders and go away. It's pointless. They can't use a French fry. But your digestive system can take the carbohydrates, the starch that's in that French fry, and they can break that starch all the way down to glucose. And as glucose, that's a 2x4 for a cell, and they can manipulate that. So be mindful when you're reading about carbohydrates, lipids, proteins, and nucleic acids. All four of those things have 2x4 versions, and they have 40-foot tall pine tree versions. If you just go around memorizing the 40-foot tall pine tree version, and you don't memorize the 2x4s and 2x6s and 2x8s, it'll get you in the end. It'll be more difficult for you to understand why you have these things. We're using this stuff because we want to eat something. Your body's using this stuff because it wants to build something. It wants to make something. It wants to construct something. And so you have to deconstruct it to give it the resources that it needs so that it can build up something awesome later on. Well, that's all I got for you for chapter 2. If you have any other questions, just shoot me an email and let me know. I'll be responding to email most of the day tomorrow. Talk to you guys later.